Hi, welcome to the Slack Chat podcast. You have Stuart Winter, the maintainer and creator of Slackware Arm, and myself, Exaga. I'm the maintainer of the SAPI project. Hello, Stuart.
Hey Phil, how are you?
I'm very well, thanks. Yourself?
Yeah, I'm all good, thanks.
Last podcast, we touched on the trust you have in the software you're downloading and using. I'm interested to hear what you've got to say about that because you are the creator and maintainer of Slackware Arm. Obviously, everybody downloading and running that software is putting quite a bit of dependence on you to create and make that software so it's usable and does what it says on the tin. Quite a few people have issues with the trustworthiness of the software that they're downloading and installing. And yeah, what are your thoughts on that? Because there was a post on the Linux Questions forum recently, which quite a few Slackers got involved in, and it revolved around the whole issue of trustability and whether you can verify a certain piece of software is going to do what it says it's going to do without any problems or issues.
This came from a poster in the Linux Questions forum who'd been looking at trying to get Firefox to build on Slackware ARM, and Firefox requires a package called Rust. That's the name of it. And they had concluded that Slackware required some quote untrusted binaries to build Rust. It was to do with an error message that came up when you were building Firefox. Anyway, that's not quite true because that's just an error message and it made it look like that's how we package Slackware, or that's how you're supposed to install Rust and these kinds of things. And then that escalated into a much broader conversation about trusting binaries. And I was trying to point out that you're already using a binary distribution. I mean, all Linux distributions are binary, even if it's Linux from scratch, or if it's Gentoo, or one of the ones that are ostensibly built from source. Even with something like Gentoo, you have to start somewhere. You have to have a platform upon which you build your new from source operating system.
Mm-hmm.
So you have to have a platform upon which you do anything. And what I was really trying to get to and point out was that, yes, okay, maybe you have to get a binary from somewhere every now and then to bootstrap your way into building something from source. But you can't escape the fundamental fact that you have to start somewhere. So you have to take a leap of faith and install something and then apply all of these security practices that were being discussed upon that. So yeah, I thought I'd give a little bit of an insight into how the open source ecosystem actually works, just using really my own experience. So as I said, this particular post came from a poster trying to get Firefox to build with a Rust package. And the way it works is that the Rust language compiler is actually written in Rust itself. So that presents you with a chicken and egg problem, because how do you get to compile a language where the language itself is written in the language for which you need a compiler for? Mm-hmm. So what you do in these instances, at least in this instance, and most of the others as well, GCC GNAT is another example of this. You need to get an existing compiler binary toolchain for your architecture. And the Rust developers provide these. They provide them for ARM, and they provide them for every architecture that I'm aware of that's currently maintained. And
yeah.
So you have to use one of these existing binary toolchains, and then you build your own Rust package for your, in our case, for the Slackware distribution. So all of the vendors of open source, they have to do it this way. Now you can go back, and Alien Bob in the team had pointed out that originally Rust was written in a different language, and that's how that's how they built the first compiler, because they wrote the original Rust compiler in a different language. So that doesn't really help you that much, because even if you wanted to go back and, let's say, rebuild your own Rust package from the original language, well, when do you stop? How does the previous language get compiled? What language was that written in?
Yeah.
Was that written in C? Well, where did your C compiler come from? there's a lecture by Ken Thompson, who's one of the original authors of Unix, and you can Google that. And he describes how he introduced into the original Unix C compiler the ability for it to self-replicate backdoors. So even if you looked at the source code line by line of the C compiler and said, oh, well, it looks good to me, then you compiled it from source. The thing is, you're compiling it with an existing binary C compiler that was provided to you by the vendor. Mm-hmm. And so if that original compiler is tainted, so that even though when you look at the source code you supply it to compile has no backdoors in it, the compiler itself is actually inserting backdoors. So it perpetuates itself like a virus does.
Right.
So I'm not going to go into more in that. It's best that you, if anybody's interested in that, listen to the lecture by Ken Thompson to understand it more. And the thing is that what he was trying to point out is that this root of trust, it's perception. You assume that the people that give you these operating systems, the vendors, so you assume that they've taken care of everything and everything is pristine and clean and it's all good. There's no bad stuff in there. And I asked the original poster why it was that they had downloaded and installed Slackware ARM. And the answer was what I expected. It was that the Slackware brand has been around for almost 30 years at this point. And in the case of Slackware ARM, I've been running that, building that, maintaining it for 18 years at this time. And so that Slackware brand, like all the others, Red Hat, Ubuntu, everything Arch, all the other ones, Debian, they've been around for a long time. And so they're also trusted within the open source ecosystem. And that's also why many other, cloud platform vendors and so on use those operating systems in their cloud platform. You don't get to see them as consumers of it, but that's what's running often in the back end. So the thing is, though, is that, trust it's perception. It's pure perception. It takes years to build the trust, doesn't it? I mean, it takes years to build the trust, the capital of trust within a brand, but it can be wiped out overnight.
Pretty much so, yeah.
Yeah, if you look at the media and you look at data breaches and so on, a lot of a brand's capital is in trust. It's, that's how they charge so much money because, we've got the trust. We've been doing it for long. We make good stories about how we do everything and how we keep everything clean and all this kind of stuff. And, apart from the huge fines that are levied at companies due to data breaches, if credit card details are stolen from a company and it's proved that was, they hadn't done all they could to secure their systems, the fines are enormous. Yeah. Absolutely, mind-boggling. At least to me anyway. And the other thing is that the brand's reputation can be seriously damaged. And that's one of the reasons why security is such big business in terms of money, because there's so much at stake. Yeah. Phil, why do you trust Slackware? Why do you trust what I put out when you didn't know me at all? You just downloaded what you found online.
Yes, Stuart. I mean, you mentioned perception. I always say perception is 99% of everything. With your Slackware ARM, it's pure faith. Download the software, install the software. Obviously, the Raspberry Pi isn't my first venture with Slackware ARM, but it's where I've done 99.9% of the work, and the learning curve has been on the Raspberry Pi device. I've never had any reason in the 8 years that I've been using Slackware ARM to question anything that it's done or it's designed to do. Certainly in its operation, it's the only time it's gone wrong is when I've done something to make it go wrong. Pretty much flawless. As is Slackware, I always say there's very little disparity between Slackware x86 64 and Slackware ARM. Unless you dive into it, you would think you're using the same system.
Right. And that's a good point. It's not about security per se, as in the hygiene of how things are validated and all that sort of stuff, which I'll talk about in a minute, but it's securing the brand. So, for example, if you saw that when you went onto a Slackware ARM box that it just wasn't quite right and things didn't work properly. You'd start to have doubts about this product, right? You'd start to wonder, wouldn't you?
Yeah.
And that's also why you and I are still talking, because when you first approached me with the work that you put out into the community for the Raspberry Pi support for Slackware ARM, it was obvious to me that you cared about how the brand was represented in the ecosystem, within the industry, within the community. So that was pretty obvious to me. And so therefore, even though Slackware isn't my brand, it's the fact that I use it is because Patrick said I could. So that I take great care that when I put things out into the wild, that they're as good as they can be, and they're as Slackware-like as it can, within the skills and the time and all that sort of stuff that I have available to do that. That's why you need to be protective of the brand within the community. You can't just have people saying, oh, this is Slackware for XYZ architecture, because yes, okay, you've taken it and you've taken the source tree and you've built packages, but it's not your brand to use. If you haven't sought approval to do that, then you really can't do that. That's what trademarks are for. And again, it's not to do with security per se, but it's to do with security and trust in the brand. And so that's a really important part. So let's start peeling back the covers a little bit. First of all, let's think about who is in open source. So when I said to the poster, why is it that you've used Slackware ARM? They said because it was a trusted brand, as Raspbian is trusted because it's marketed, but it hasn't been around as long. But there's some trust built out there. People are using it. There's talk about it. So that makes sense. But who's actually in there anyway? Who is it that actually contributes to this open source? In the same way as I've never met you, and I haven't met any of the Rust developers, and probably never will. I haven't met most of the Slackware team itself. I've met a few people. But when you think about the thousands of packages in Slackware and in other distributions, there are far more packages than Slackware has. When you start to think about, well, hold on, I don't actually know any of the people who contributed to, who produced, who checked. I don't know the people in this chain. I do see what the vendor gave me, in our case, Slackware, but actually, who are all the people that built this software? The Slackware team didn't build Rust. We didn't write Firefox. We didn't write Bind. We took it from somewhere else, and we assumed that, we hoped, you take a leap of faith that it's what you're taking is good. But that's not always the case. There are many times when, not because it's deliberate sabotage or anything, but where there are security bugs in software all the time. It's the same thing. And that's why there are so many security updates for operating systems and software, because the software has been written by individuals, by programmers, developers, and they implement what they think is good, best security practice. And so these days there's lots of good practices, best practices that you can adopt when you program, but that doesn't preclude a simple bug being put in there by accident, or someone implementing it slightly wrong. It works, but yes, there's a gaping security hole. You can call that whatever you like, but it doesn't preclude the fact that mistakes happen. And I know we've talked about this before, but there was a time in the 90s with the pirates who would pirate games on say the Amigas, STs, and so on. And in the media, I don't know if you remember, but the media would say that pirates were distributing viruses on these discs that they would distribute.
Yeah.
So I was interested in this a while ago, and I was looking at some of the forums, and some of these old names who were in the on the pirate crack scene years ago, they turned up on the forums, and I recognized them. And one of the people actually responded directly to this and said, "This is nonsense. None of the people in our crew, or none of the people in any of the other crews that we knew about, the pirating crews, no one ever put viruses in there, because of the way it worked. The way that they worked, they had to post discs to their friends in the crew, and then likewise they would share the original. Someone would pocket a disc from the duplicator, and then they'd give it to the pirates." And he said, imagine if we put viruses on there, we'd wipe out our entire disc collection. No one wanted to do that. Their goal was not to make viruses. Their goal was simply to crack software in any way that they could and get it working and distributed. That was the game for them. It wasn't even about the game as in, the playable game. The game was the cracking. That was the fun part. It wasn't making viruses. So And and how many people took these pirated games and just ran them?
Yeah.
But what's the difference with that with open source? You still don't see who it is that contributes. So let's think about this. Let's look at the workflow. Let's start looking at some of this, I guess you'd say, the substrates. Let's say that I want to update one of the packages that's in Slackware ARM. I'll pick U-boot tools. So that's one of the ones that's just in Slackware ARM because it's required for the boot process. So what I do is I download it from the U-boot website, which is over TLS, which is Transport Layer Security. And I then verify using the signatures that are provided by the U-boot developers. And there are other ways as well. You can also verify the payload with a hashing algorithm like MD5, but that's not actually that secure. GPG, GNU PGP, that's as secure as it, that's pretty much what we've got. That's the industry standard. Although actually, quite funnily, when I was at Red Hat, some of the trainers there, they would, when they run their training courses, they would introduce PGP and how that's how the package is assigned, and that's the best that there is, and it hasn't been. And he said any time there was anyone from GHCQ or the UK's NSA type of thing, they said that they would always get these sort of instant grins from the from those training participants, because they it was obvious that they knew something that we didn't know, and now we know that with all of the leaks and WikiLeaks and all that sort of stuff, we know why that is now. This was years and years and years ago. So we take all of this stuff and we download it from the web and then we verify it. But let's look deeper into that. Why is it that I trust a TLS encrypted or TLS secured website? Why should I? Just
perception.
Yeah, it's perception. There's, when you actually look at what's going on, there's a trust chain there. When the website presents its certificate to the client, the client being the web browser or wget or whatever, that certificate that's presented by the web server is validated using the trust chain in what's called the CA cert store. So I've forgotten the package in Slackware now. I think it's CA certificates. And inside of there's a whole bunch of, there's loads and loads of certificates. And what that allows you to do is to verify that this certificate presented by this web server has been signed by a known trusted party. So there are many like Komodo, VeriSign, Encrypt. All of these, there are other ones as well, but so those are some of the main. So basically, you've got a copy of the certificates that Slackware ships, which come from, I think they come from Mozilla. I'm not sure actually. I need to check. My point is that the software is verifying this certificate from the website using a package that your operating system vendor shipped up. And that's what's going on there.
Yeah.
But when you dig deeper into that, well, who are these companies? Who's VeriSign? Who's DigiCert? Do I work there? Do I know if they really take it seriously? Do I know who it is that's doing this? Do I know that these certificates weren't erroneously supplied to the person that's running the website? I don't know that. And that's one of the things that Google did. They researched Symantec and figured out that Symantec were issuing certificates that they really shouldn't be.
Yeah.
And the security process wasn't being followed correctly.
Mm-hmm.
I'm not going to go more into that on this podcast. You can Google that and find that pretty easily. But my point is that actually, yeah, okay, I'm assuming that these vendors, these security certificate vendors, that they've got their act together. But you don't know that that's true. You assumed it was for years until someone in Google went, I'm not sure about this. Let me check this out. And then we go back again. So I've downloaded the content. It's over an encrypted channel that's been verified by software that I didn't write, using technology I didn't invent, using a verification system that I don't have visibility into. I just hope it's being done properly. And then I'm going to verify the payload, the archive, source archive, with GPG signatures and all that kind of stuff. All right, so that we've kind of done that. That's what you do. That's what I do. It's what anyone does, and it's what anybody in the community, anyone can follow those steps. I mean, that's just the basics of how it works. And then the second part is you need to publish it. So you compile the package, you build it, and then you have to publish it onto the internet. And how do you do that? Where do you do that to? In my case, I publish it to the master FTP server. I used to run my own, and I stopped doing that because it was just too much work. I now use Darren Austin or Tadji's server because I've known him for years. I used to work professionally. I trust that he's got that master server as secure as it can be. Now, it doesn't mean that there aren't exploits for it that no one but some black hat hackers are aware of. It doesn't mean that, but I'm just going to have to take a leap of faith and assume that that is the best that it can be.
Absolutely, yeah.
But with some other projects, you'll find there are cases where the source code has been tampered with and no one realized for quite some time. These are real things that happen. You can try all you might to prevent it, and hopefully everybody does. And I'll talk about that a bit more in a minute. But at the end of the day, you still have to take a leap of faith. And at some point, you end up with this platform, this operating system platform, this collection of tools and packages and all that stuff that you're using to do your work, to do your development. And it could be that there are latent issues in this software, whether it's deliberate or whether it's just because it's a security issue that someone found later. Again, what we do in the open source world when you're a developer, a contributor to any of these projects, is you follow the same basic processes that anybody else can do and does do. Even if you don't publish anything yourself, you still may download things, whether you download source or compile it, or you download binary packages and you just use them. Mm-hmm. But even as an open source vendor, we don't generally download other people's binaries and use them. And Rust is just an example where you have no choice. Usually you're downloading source code, but again, it's still developed by people that we don't personally know, hosted on servers that we don't run.
Well, yeah.
Yeah, and we don't know if the servers have been compromised and have modified versions. It's simply impossible for us to verify this stuff.
And not forgetting, you're talking about Rust a lot, but it doesn't only apply to Rust. It applies to every single piece of software that you use and install.
Yeah. So, we've talked about how you need to take a leap of faith and hope that people have got their security hygiene in order because you don't have that visibility of it. Now, when I used to work for a UK military company, I had secret clearance, so I could look at designs. I wasn't supposed to look at them, but that was my job was to manage systems that housed the design. So inevitably I got to see things on screens and whatnot. Yeah. But just to get that secret clearance, there is a process involved that you have to fill in lots of paperwork, and then they do their research on you as an individual. And inside of those institutions, security is taken extremely seriously. Everybody is well versed on how to act and what to do. You'd have the security guards walking around throughout the day and night. They would just randomly check filing cabinets to make sure that the security dial locks were properly locked, so you couldn't go and retrieve, say, a disk or pull out some confidential information. And all of the network was fully secure as much as it ever can be. You couldn't, for example, on a website, you couldn't post, when you have form boxes in websites that you can fill in data and click submit and so on.
Text field boxes, yeah.
Right. So there was a maximum field limit on those boxes. So you couldn't, for example, publish a lot of data outbound. It would simply the security systems they were using, and they would intercept. They were essentially a proxy, and they would check that kind of stuff and intercept it and cause it to fail. So your client you'd get an error, a failure message from the web marshal because you tried to put too much into a form box. So they had, and that was just one thing. Of course, they had all of the software on the client machines to stop you inserting untrusted USB sticks. And there are places where it's taken extremely seriously, and it has been since those institutions began. This was the RAF, as it happened, the Royal Air Force. So this kind of stuff has been baked in from day one, as far as I could tell. Right. But that's not the case in certainly most of the vendors that you work for. Security has been added, certainly in some people's minds, they've always thought security, but certainly in my experience, security has come far more to the surface in, say, the last 12 years. But in general, I've not seen that kind of level of security outside of anywhere where it's been baked in for a long time.
Mhm. I don't think it matters whether you know the people or not. I
No.
don't know how much relevance you put on that. And you said you've met a few of the Slackware team. Developers on that level, you wouldn't question. But if you met old Philly boy who's the maintainer of SAPI, I mean, would you trust his software? Would you download and run and install the SAPI installer to put Slackware ARM on a Raspberry Pi? Or would you say, nah, we're going to do it the manual way, or whichever method suits you? In my way of thinking, you said previously in the podcast that trust is built.
Mm-hmm.
I completely believe that. So when I first downloaded Slackware ARM, I'd had about 7 or 8 years using Slackware, and I expected it to be completely different. In fact, the thing that surprised me was I couldn't believe how much like Slackware it was. No experience of ARM devices or the ARM operating system, and it took me quite a while to realize, because I wasn't talking to anybody else except a friend of mine at the time. It took me quite a while to realize that it's meant to be the same in every possible way. It's meant to be the same. And that actually made me trust it a little bit more.
Right. I'm glad you said that, because that is one of the key things, is that if you've got the trust of the Slackware brand in our case, and it's been around for 30 years or so, and it's stable, it's reliable, it's maintained by the same person who created it, who continues to maintain it. So that's Patrick Volkerding. So he does that. And I've maintained Slackware ARM for about 18 years at this point. It's never been anyone else. Other people have contributed to it. Other people that I trust have had access to change things in the past when they were hacking on it initially. And I trust that person, and I still do. But no one else knows him. I know him personally. I've met him many times. But for you, why do people trust what you've put out there? Well, the way I look at it is that you could say that about any software. Is why do people download and install anything? Why do people take pirated games, which are known to be produced by people who have ripped off the protection? Why would you run that? Well, you do that because you didn't want to pay. Mm-hmm. And in open source, you do that probably because you don't want to pay, or because it's good and it works. And I think that most people don't actually, I don't know, this is a massive assumption on my part, but I think a lot of people don't actually think it through, what it is they're actually doing. And so they just download it and install it. But again, as you were saying, if you'd installed Slackware ARM and found it to not really replicate the x86 experience, if you suddenly found something just blew up, the packaging system just stopped working, or some weird error came, you'd start to have doubts about it. So therefore, it's really important that when I put things out, that it's as best as it can be, because that's part of the perception of trust. Again, if you go back to it, really, there's no reason why you should trust anything that I do, because you don't know me. Yeah. And you also, and this is the whole thing. Again, everything boils back down to a leap of faith. And you have to assume that the people that work in open source, but also the people that work in vendors, they have their basic hygiene. And in the same way as we have to take, as the vendor, we have to take a leap of faith that the developers of the packages that we consume, and as a downstream consumer, that they take their security hygiene seriously, that they verify the source that they're building. Because bear in mind, the developers of the software that we include, they're not necessarily using Slackware. They could be using anything. Yeah. So we're reliant upon the vendors that they use to build their packages that we consume. Everything is interlinked. It's all interlinked. And when you've got, and then you've got people like, the only one that comes to mind is Travis Ormandy, who he's a security researcher at Google, and people like him, they use source code analyzers and they do it by hand and all these kinds of things. And that's their gig. It's what they do. It's what they love. And what they do is contribute their findings and fixes back into the community at large, back into those software projects, so that the vendors such as Slackware, such as Red Hat, etc., will end up with more secure software as the journey moves
Yeah.
forward. And that's it. The question of whether I trust or why I trust anything, it kind of doesn't really matter that much, because when you boil it down to the substrates, everybody's using the same kinds of stuff anyway.
Mm-hmm.
Everybody's having to use the same technologies really to verify things and to upload, to publish, all of those things. So again, it goes back to perception, or it goes back to not having thought it through, or perhaps that you just need it. I mean, in the case of U-Boot, well, what am I going to do? I'm not going to go, I don't understand what's in the code base anyway. So you can hack a little bit to change a few parameters and that kind of thing. But who's realistically going to read all of the source code for one project, let alone thousands? And anyway, even if you did, there are plenty of examples where people have written software for years and it took some outsider to go, but you've got a gaping hole there. Look at this.
Yeah.
Because, it's like when you have an editor who reads your book. If you're writing professionally, you have an editor that reads it because there's a second set of eyes that doesn't have your mind, so they don't gloss over some of the words or some of the incorrect grammar or anything. They go, okay, well, I've got a fresh set of eyes. Look at this. I found this here. You should fix it. Mm-hmm. And it's the same with source code. So again, it all boils down to a leap of faith, whether it's a commercial offering or whether it's an open source free offering. In my opinion, you've got to start somewhere, and you simply hope that everyone's secured the network that they develop on, that they've got the latest, the actual operating system platform they're using to develop on has all the latest patches and all that kind of stuff. That's kind of it.
Reading the LQ thread around this, it's confusing, because let me just read basically what it said. Blindly downloading untrusted binaries in order to get something you urgently want is the exact type of thinking that has led to multitudes of people's computers getting Trojans installed on them. Now, I'm sure, if you're like me, Stuart, if you use any software that compromises your security in any way, shape or form, you will never use it again. Once you are alerted to the dangers, that's when the reputation of the software goes swiftly downhill.
Well,
and it's like, what did they used to use? The Adobe Reader.
Acrobat.
On Windows. Mm-hmm. I mean, I remember going back a couple of decades, you could hardly download it from anywhere without it being hacked to bits and fiddled about with.
Right.
So, I mean, the only time I ever installed it was from like an official installation disk or something like that. Mm. I daren't download it online from 2Cows or, any other file sharing repository. It got a reputation, and in the end nobody would use it because, well, everybody who was aware wouldn't use it because they knew they were asking for trouble. And with software that you download and use and don't have that risk of failure of trust, it's never a question. So when somebody says blindly downloading untrusted binaries, if, for me, and this is me personally, if I've got no reason to question the trustworthiness of the software that I'm installing from you or any of the other Slackware team, then it's never an issue. So why make it an issue? Obviously, if you guys download the software for whatever reason to get something built or a new package or whatever, you're going to test it. And you're at a level where you don't just say, right, it works, and then ship it out. Because Slackware software is only released once it's tried and tested and proved. That's why you don't get a Slackware release every year or every few months, like some other distributions, because it's only released when it's ready.
Well, it's part of the reason, yeah. But I think that you're right. If you, for example, look at Windows 10 and other versions prior to that, a real example is when I download Putty, the terminal emulator. When you download and run that, you'll find that Windows says this is not a known, or something like this. It's not a known trusted vendor that's in the trusted vendor store on Windows. I don't know Simon Tatham, but I assume that he's not going to spend his time and money getting putty into Microsoft's certified vendor list.
Yeah.
Right.
Yeah.
So you have to take a leap of faith and hope that, yeah, it's a good binary. But even so, there are many examples, and Android is a really good example. I'm just picking them because they've been in the news that I've seen, where you have some apps in the App Store that were okay, supposedly, and then they get removed because Google or Apple, they run their tools and find that these packages they're nefarious, they're up to no good, and so they pull them from the App Store. But yet they were still in there to begin with. They were verified. You assume that when you pick an app from the App Store on the mobile phones, that everything is good. Yeah. But that's not necessarily the case. And again, it boils down to you took a leap of faith. You hoped it was all clinical and clean, and it may not be.
Yeah.
And that's really what I was trying to point out, that this is just a bare fact. It really is. Whether you write your own software and never give it to anybody, which many of us do. I've got lots of it that I don't put out anywhere. It's still running on a platform that I didn't create. And even when I'm running them on Slackware ARM, well, I still didn't write all the software that constitutes that operating system. It's as simple as that. That's the essence of it.
Yeah.
Yeah.
That's one reason why I like to keep SARPy as unaltered as possible from what Slackware is, because in order to maintain the reputation and trust in the brand, I have to stick to what you do pretty accurately. I can't go including things and changing things just because I think it's better.
Yeah.
Or I'd like it to be so. I mean,
yeah, that's great that you do that, and I know that you really care about trying to keep it, in the original style that it is.
Yeah.
But for example, I do make changes to the installer. I have to, because I need to for ARM. So but some of the changes I make, I eventually push them back upstream to Slackware if I know Patrick's going to take them. Any changes that I make are only purely because I need them for ARM to make it work. Phil, I've got to go and cook dinner now. So, okay. But yeah, I can't think of anything else really to say about security that we haven't covered already. But I'm really interested and really curious if other people have got different views. I mean, you're certainly welcome to come on the podcast and let's talk about it.
Definitely.
All right. Cheers, Phil.
Thanks for talking.
Have a good evening. Cheers.
Bye for now.
Bye.
Bye-bye.